Hello. Today I will be presenting my thesis project, which is estimating Oregon's forage production potential using GIS-based modeling and mapping techniques. For today's presentation, I'm going to focus on my first objective, developing quantitative tolerances functions for forage species used in Oregon. However, this project will also include mapping suitability zones for species based on climate and soil, predicting potential yield for total and seasonal production, validating model estimates, and estimating livestock carrying capacity for Oregon. So why are we doing this project? Identifying and selecting appropriate species for specific environments and predicting their seasonal yield are essential components of sustainable forage livestock systems. Current methods are inadequate, and they depend on a limited number of trials and experience of farmers and university specialists who continue to retire over the next few years. New methodology is needed to accurately predict species suitability and their potential yield. Computer-based tools are now available which can be used to quantify climate and soil tolerances and simulate yield across the landscape. This project will assemble historic data, expert knowledge, and modeling and mapping techniques to improve the process of species selection. Forages are the foundation of sustainable forage livestock systems. In Oregon, diverse topography, climate, and soils further complicate the species selection process and seasonal yield profiles. The impact of this project will be greater establishment success, improved persistence, higher yields, and reduced feeding cost. So we heard in the presentations this morning about how important forages are to the nation. This gives you an idea of how important forages are to Oregon. As you can see, we have a diverse agriculture in the state. However, cattle, dairy products, and hay and forage are some of the biggest pieces on this image. This table shows that out of all crops, hay and forage and grass and legume seeds are in the top 3 commodities for crops, and that cattle and dairy products are the top 2. According to the USDA, cattle and calves are Oregon's second largest agricultural product, with a value of over $650 million in 2012. Hay production is the third largest agricultural product, with a value of over $630 million. Forages also provide 50% of feed for dairy cows, which had a value of over $500 million, and the majority of feed for sheep and goats, which had a value of approximately $23 million in 2012. The previous work that has been done in this area include traditional plant species suitability maps, which were typically hand-drawn and based primarily on minimum temperature. The USDA plants database has defined where species have occurred, but does not give any suggestions or recommendations for specific areas. And the PRISM system, which was developed by an Oregon State University scientist, Chris Daly, has developed detailed and accurate 4-kilometer climate grids for temperature and precipitation for the US and China. Extension publications are another area where information is often found for this. However, they typically rate species as excellent, good, fair, or poor for a variety of conditions, and they are typically not location specific. So while they are a great source of information for different species, they do not provide recommendations for specific areas. Web-based tools, such as the Cornell Forage Species Selector, Penn State Forages Selection Tool, and Pastures Australia Pasture Picker, are available and let users find recommendations based on their county and soil type, as well as management, intended use, drainage, soil, pH, soil texture, and topography. Pastures Australia's tool has been developed for the entire country, and they have options for climate changes that the user can do. However, the Cornell and Penn State tools are based primarily for their state and do not include any climate change that the user can make. My project will be mainly focused on the climate aspect of species suitability with soils information taken into account. So assessment of Oregon's forage production potential will be based on satellite land cover and land use images, as well as GIS-based forage species modeling and mapping techniques. The first steps of this project include selecting cool and warm season forage species, identifying Oregon's ecoregions, creating a table of characteristics of each region, including climate, soils, and potential forage species, locating climate and soils maps for each region, and choosing representative sites in each region for crop simulation model application. Here's a list of the cool season species, the key forage species we will start with. This is not a comprehensive list, though, because we would like to add species as we go through the project. Here's a map of ecoregions in Oregon that Oregon State University range scientists constructed. More recently, though, the EPA has divided Oregon into 9 main ecoregions with over 60 subregions. I will be using the 9 main regions defined by the EPA, but dividing them differently so they are more practical for producers in our state. Here's an example of a region characteristics table that will be constructed. As you can see, this gives you an example of some of our differences in Oregon. Precipitation on the Coast Range can range from 50 to 200 inches annually, whereas somewhere like the Snake River Plain only gets 8 to 12 inches. Here is a precipitation map, which will be one of the climate maps utilized. And I've zoomed in to show the Willamette Valley so you can see a little bit more of the detail of the map. There's also an average extreme minimum temperature map. And again, I've zoomed in so you can see the detail a little bit more. And then here is a state soil map. We will use this as a reference, but utilize more detailed county-based maps in the project. We will be choosing 3 representative sites per region. And these sites will be chosen based on experiment station locations and data from a previous experiment. Here's the map of the EPA ecoregions again, and I've added stars for the locations of the different experiment stations in Oregon. So with this as a starting point, you can see that most of the ecoregions are represented with at least 1 station. Yield prediction models. Yield prediction will be based off of simulation models such as GRASS, Almanac, Dairy Mod, and the PRISM model. Validation of our results will be done through previous experimental data and expert knowledge from extension agents and local producers. When this project is finished, we will present the information in extension publications to give a background knowledge on what we've done. We will also be constructing a website that users will be able to put in climate information, as well as detailed soil, intended use, and the other inputs specific for their location. Eventually, we would also like to develop an app for smartphones and tablets, which would allow the user to take that out into the field with them and automatically have soil and their climate information inputted into the model. In summary, this project will develop an improved methodology for selecting appropriate species, estimating total and seasonal yield, and matching forage livestock systems to the biological capacity of the land. Current and emerging technologies, such as satellite imagery, crop simulation modeling, and GIS-based modeling and mapping techniques will be used. Oregon is being used as the test case in collaboration with a similar project in Sichuan Province, China. Follow-up projects are also planned to extend this methodology to the national scale. Potential benefits of this project include increased probability of successful establishment and persistence. It will help guide management decisions, help conserve resources, and improve profitability for our producers. Future applications include applying this model to other states, nationally and internationally, and using it for climate change and adaptation strategies. I'm very excited about this project and think it will have a huge impact for Oregon. I invite you to come visit us and let us tell you more about this and how it's helping our farmers and ranchers. Are there any questions? Yes?
How is this different than NRCS also
So the question was, how is this different than the NRCS pasture suitability groups? That's not one that I've looked at, so I can't say for sure. But we're doing this really specifically for Oregon with multiple locations in each region. And so I think part of the difference will be that we will have data from each of those sites put into this model to validate our results.
What do you envision be the content of the application, of the phone app?
So the question was, what would the content of the phone app be? Since this project is still in the planning stages, we're not quite there yet. But the hope would be that the user could go out and automatically their location be inputted into it. And then they would be able to select some options for their intended use. And then it would provide them with recommendations.
Any other questions for Brianna?
How extensive is the warm season component in Oregon, thinking particularly of the perennial switchgrass?
So the question was, how extensive is warm season grasses in Oregon? It's not utilized very often. However, there are areas in Oregon where we can grow it. So like most of eastern Oregon, the temperatures get high enough and there's not a lot of precipitation, and I mean, they could grow well there. But they're not utilized very much in Oregon.